Hey guys, in this video we're going to take a look at similar triangles, the application of similar triangles, and how they're used to solve problems, to solve for measurements where you can't measure them directly. So that's why it's called indirect measurement, and it's a method of using proportions to find an unknown length or distance in similar figures. And I've drawn the most common three similar figures that you could see, and when you're looking at these, side AB is going to match up with ED, and side BC is going to match up with DC, and side AC is going to match up with CE. And the reason why I'm telling you this is a lot of times in the problems they aren't going to give you similarity statements to work with. Like if you look at this first problem we have here, there is no similarity statement. So you're either going to have to write one yourself or kind of know the rules for how these work. So with these, you could go AB matches up with ED, and then BC matches up with CD. It would be DC. And then AC is going to match up with EC. So if you needed a proportion, those are the different ratios that you could pick from to write your proportion. Kind of the same idea whenever you're looking at the next one. FG matches up with HJ. And then this one's kind of tricky because you've got HI, but then you have the whole thing GI. So FG is the big one, so GI is going to match up with HI. And then you could also go this third side here, but then again, there again, you have to watch for that side and this whole front side here, because we're looking at triangle FGI and JHI. So FG, GI, and then we'd be going FI over JI. And so triangle similarity statement would, for this one, would be triangle FGI would be similar to triangle JHI. And if we did the same thing over here, triangle ABC would be similar to triangle EDC. And then looking at this last one, we've got LK would match up with KN, and then JK would match up with KM, and LM would match up with JM. So there again, LK is going to match up with NK, and then MK is going to match up with JK, and then LM, and notice it went pink to blue, so I'm going to go pink to blue, NJ. So those are the ratios that you could use to write your proportion, and you would pick 2 out of the 3. You wouldn't want to use all 3. So if we start getting into problems to solving, they want us to find K, and they gave us 4 values, which is what you're going to need, or they gave us 3 values and 1 unknown, which is what we'll need to solve, because with a proportion, you've got 4 parts and 1 unknown to solve for. So if I'm looking for the first side, we're looking to solve for K. And this side K, or LN, goes from 1 arc mark to 2 arc marks. So we're looking for the same thing in this picture here. Well, here's 1 arc mark to 2 arc marks. So if we write that down, we've got LN is being compared to JN. And that's going to be equal to, and since I started with this triangle and I did this one first, I'm going to do that one first and then that one second. So we've got that part right there. So I went from 1 arc mark to a 90-degree angle, and here's 1 arc mark to a 90-degree angle. So we've got LM going to JK. So there's our proportionality statement. So now we just need to fill in the values and solve. LN was the value we didn't know, so we'll mark it as K. Jn is 10, is going to be equal to LM has a value of 4 over JK is 8. So to solve for this, we're going to need to cross multiply and divide. So we're going to do 8 times K is going to give us 10 times 4. So 8K is going to be equal to 40. Divide both sides by 8, and K is going to be equal to 5. So that would be our answer. K is equal to 5. So that means this length right here is going to be 5. And you can kind of use the pictures as a way to double check and make sure you've done this right. You can kind of see how these values are bigger than that value. And so if you'd gotten a number that's way bigger, like if we gotten 25 for this, we would have known that we would have made a mistake, because if this triangle is bigger than that triangle, you can't have bigger values here. Looking at the next one, they were nice and they gave us the similarity statement. So in the diagram below, triangle ABC is similar to triangle ADE, and they want us to find G. So here's G, and they tell us AC is similar to AE. So here's AE right there. So AC is similar to AE. And then the other part that they give us information for is this one right here. So we've got CB is going to match up with DE. So CB is going to match up with DE. Okay, so AC is G over AE is 95, is going to be equal to CB is 32 over 64. So if I'm comparing 32 to 64, this one's smaller. So that means whatever number we get for G should be smaller than 95. So to solve, we need to cross multiply divide. So 64 times G will give us 95 times 32. So 95 times 32 is 3040, is going to be equal to 64G. Divide both sides by 64, and G is going to be equal to 47.5. So that's our value for G. And just to double check, we said it should be smaller than 95, and it is. Looking at another type of triangle that you could be given. For this one, they want you to find H. And for these, you need to be very careful because you have a big triangle, MLO, and inside that big triangle, you've got a smaller triangle. And if you're a person who has trouble seeing the difference between the big triangle and the smaller triangle, draw them out as two separate triangles. So if we do that, we've got our big triangle, and it's MLO. If we're looking at ML, it has a value of H. If we're looking at LO, it has a value of 6. Now with this, you have to be careful. This one was a really nice problem. They told you exactly how big LO is, but if you had a problem like this one, you would have to do 8 plus 16 to get that whole length there. And then they don't give us any information for MO. And then looking at the smaller triangle, you've got NPO. This one's 4, and this one's 3. So if we're comparing same sides and same parts, we're going to have ML compares to NP, and that's going to be equal to LO compared to PO. I'm going to move this up there so I don't run out of space when I solve. So ML has a value of H over NP has a value of 4, LO has a value of 6, PO has a value of 3. So cross multiply divide, 3H is going to be equal to 4 times 6. 3H is going to be equal to 4 times 6 is 24. Divide both sides by 3, and H is going to be equal to 8. And again, I'm going to use the double check. If I compare this number that we have here that we've been given to that one there, this one is smaller than that one. So this one should be smaller than whenever we get here. It is. 4 is smaller than 8, so we're doing okay. Looking at this next one, I'm going to do this together as all one big one. So look in here, I've got I, J, G, and they want us to solve, get HF. So looking at, here's the little triangle. I've got HF compared to, looking in the big triangle, the one that matches up to it. And just to remind myself, I'm going to put a little arc there. And then 16 plus 8 is 24. Just to remind myself that that whole big side is going to be 24. So HF is going to compare to IJ. And then we've got the bottom, FG, is going to compare to the whole big bottom down here, which is JG. So HF has a value of G. IJ has a value of 45, is going to be equal to FG, has a value of 8, over JG, which has a value of 24. So to solve for that, we cross multiply, divide. So we're doing 24 times G is going to be equal to 45 times 8. 24G is going to be equal to 45 times 8 is going to be 360. Divide both sides by 24. And G is going to be equal to 15. So that means that value is 15. So 8, 15 smaller than 24, 45. Yep, so everything's matching up okay. They could also give you problems where they don't give you pictures to work with and you'll need to draw triangles that go with them to match up. So with these, you'll draw a right triangle of whatever is going on and then write the values that you have on the triangles that you draw and then figure out what you don't have and set up a proportion to solve for that. So Shira wants to know the height of a traffic cone. So height is going to be a vertical distance, so there you go. She wants to know how tall that is. She measures the shadow of the traffic cone. So if we're looking, here's the traffic cone, here's a shadow, and finds that it is 0.3 meters. So with this section, we're doing triangles. This just so happens to be a right triangle. She also knows that a nearby outdoor sculpture is 1.2 meters tall. So there's the sculpture, 1.2, casting a shadow that is 0.9 meters tall. If you need a triangle, there's the other. You connect the two sides for a triangle. It wants to know how tall is a traffic cone. So I'm going to do the part we don't know over the part we know, and the part that we know over the part we don't know, or that we do know. So instead of question mark, I'm going to use x. So x over 0.3 is going to be equal to 1.2 over 0.9. So again, I picked this one to be on the top. So the height's on the top here, height needs to be on the top there. The length of the shadow is on the bottom there, so length of the shadow has to be on the bottom there. So to solve for the height of the cone, we've got to cross multiply, divide. So we're going to do 0.9 times x is going to be equal to 1.2 times 0.3. So 1.2 times 0.3, 0.9x is going to be equal to 0.36. Divide both sides by 0.9. And we get x is equal to 0.4 meters. So that tells us that the height of the cone is 0.4 meters. And we want to check it makes sense. Does it make sense that the cone is shorter than the statue? Yes. This one is smaller than that one, so this one should be smaller than that one. It doesn't guarantee you'll get the problem right, but it at least gives you a chance of knowing whether or not you've got it right. So looking at the last one, you got to be careful sometimes with how you read these, because they can try and be tricky. So with this one, we've got a cedar tree. And its shadow is 15 feet long. Not far away is an ash tree. And its shadow is 30 feet long. If the cedar tree is 8 feet tall, notice when you get going with a lot of these problems, it's going to be pretty much information, 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 information. This one's not like that. It gives you information, information, and then gives you the 8 feet tall. And a lot of people, I think, would make the mistake to put it there. You've got to be careful and read. This one says the cedar tree is 8 feet. So it doesn't go over there with the ash tree, it goes over here with the cedar. So be careful with the wording and labeling which side is which. And this one wants to know how tall is the ash tree. So I'm going to compare 8 over 15 is going to be equal to x over 30. So to solve for x, cross multiply, divide. 8 times 30 is going to give us 15x. 8 times 30 is 240. Divide both sides by 15. And x is going to be equal to 16 feet. So let's double check. Here's an 8-foot tree that had a 15-foot shadow. So the ash tree, taller than the cedar tree, should also have a long shadow. Does it? Yes. So we at least have a chance of getting that right. If you have any questions, be sure to write them down on your guided notes and ask me when you get to class.